Welcome to a quick video on applications of vector for areas of triangles and parallelograms. Cross products and vector operations are the two concepts that you need to know for this lesson. Let's start off with triangles. So if you draw vector A and B, and if you were to connect their heads using a line, and you give an angle theta, which separates the two vectors, then you will get a triangle. To find the area of this, the area is half the base times the height. Well, to get the base, it's pretty easy. It's just the magnitude of vector A, so we can write that down. And to find the height, we'll draw out the height first, and we form a right angle triangle, and this side is opposite to the angle, and we can just use the magnitude of B multiplied by sine theta to get the length of this side. So the area becomes 1/2 magnitude of A times magnitude of B times sine of theta. Well, if you remember, magnitude of A times magnitude of B times sine theta is the cross product of vector A and B. Therefore, the area of a triangle can be calculated by 1/2 the magnitude of the cross product of vectors A and B. For a parallelogram, we're going to use the exact same idea. We're going to draw it out first. We're going to have vectors A and B separated by angle theta, and the two other sides will be vectors, the same vectors, because they have the same magnitude and the same direction. And the area of a parallelogram is its base times its height. Similar to before, the base is exactly the same. It's just the magnitude of A. And to find the height, we draw it out. We form a right angle triangle, and this side becomes the magnitude of B times sine theta. And therefore, the area becomes the magnitude of A times magnitude of B times sine theta, which is exactly the same thing as the magnitude of the cross product of vectors A and B. The concepts of this video is summarized here, so if you want to pause the video and write any of the information down, please feel free to do so. And now we're going to look at a couple of examples. For the first example, we want to determine the area of a parallelogram which has two vectors, vector u and vector v. We know for a parallelogram, the area is the magnitude of the cross product of the two vectors. First, we will find the cross product. So to do that, we'll write all our components. We'll write the components of vector u as 3, 2, 1 and vector v as -1, 2, 0. And the cross product is equal to I. We're going to cover the row and the column I, and we're going to use the diagonal cross products. So 0 minus 2, then it's going to be minus j, and then we're going to use the diagonal multiplication again, and plus k, and we're going to use the diagonal multiplication again. And once we have all the numbers, we get -2i minus j plus 8k as our three components. The magnitude of the area then becomes the root of the x component squared plus the y component squared plus the z component squared. And when we put all those values in, we'll get the root of 4 plus 1 plus 64. And that will give us root 69, which is approximately 8.31 units squared in 3 significant digits. For the second question, we want to determine the area of a triangle with vertices A, B, and C. First thing we want to do is draw the triangle to kind of get an idea about how it looks like. And once we have that, we can kind of decide which vectors we want to use. So when we draw it out, we can choose either vector AB cross AC, or we can do CBCA, or we can do BABC. We have chosen vectors AB and AC, so the area is going to be the magnitude of the cross product of vectors AB and AC. Well, we need to find the vectors first. So first, let's look at vector AB. So vector AB, we're going to take all the xyz components of B and subtract them by xyz components of A. And when we do that, we get -1, -2, and -1 as our three components. And for vector AC, we'll do the same thing, take the components of C and subtract them by A, and we'll end up getting 2, -1, and 1. After that, we need to find the cross products. So for the cross product, we will write the I, J, and K components, and we'll write the XYZ components of AB as -1, -2, -1, and AC as 2, -1, and 1. Then we will use positive I and cover the top row and column I and use the diagonal products and subtract them by each other, and we'll do that for all the components. So it's positive I, -J, positive K. And once we have all the values in, then we are going to get our components as x component of -3, y component of -1, and a z component of +5. Now we have almost everything we need. We just need the magnitude, so that's the square root of the x component squared plus the y component squared plus the z component squared. So that's -3 squared plus -1 squared plus 5 squared, which will give us approximately 5.91 units squared with 3 significant digits as our final answer. I have prepared 2 questions for you folks to try out on your own, and I will try to post the solutions to these questions in a separate video as soon as I can. I hope that this video was helpful in giving you an idea about how you can use cross product to find area, and thank you for watching.